Okay.
Let's see if is it fine from every side. Yeah, I think it is fine.
I'll start, sir.
I think we can start.
Okay. Am I audible? Is it fine?
Yeah, we can hear audible.
Okay. Okay, sir. Okay then. So, hello and welcome everyone to the 26th edition of the Technical Lecture Series. Today we are fortunate to have with us Rajat Singhal sir, who is currently the founder and CEO at Basil Technologies India. Previously, he was working as chief technical architect at Element 5, and before that at ThoughtWorks India as an account technical principal, where he contributed to several open source projects such as Vakyansh and Bhashini for Indian languages. He has over 16 years of extensive experience in the area of architecture, data engineering, and software development. Today, Sir will be giving us a talk titled MLOps, Productionizing ML Services. So we'll be discussing about the importance of MLOps in the AI industry and state-of-the-art approaches for streamlining ML services. He will discuss various pipelines and open source tools for performing MLOps effectively. And finally, he will go through the necessary skills and current career circumstances in this field. So I would like to hand over the session to Rajat sir.
Yeah, thank you very much. Yeah, I'd like to start. So MLOps, I think, as you have seen on the screen, we're talking about machine learning operations here, going beyond the experiments that we perform on Jupyter notebooks and all. How do we make it, valuable for business end of the day, right? So that's our important. So agenda, we would like to cover like what should be we talk about before MLOps, like DevOps here. That's what I'm referring here. And then what is MLOps? Why do we need that? How do we do that, right? And then we will talk about tools and technologies to achieve that. And what are the skills to be an ML engineer? And we'll talk about the market opportunities, what are gaps in the market, how we can fit, right? And I'll just touch on the black-based technologies. We just talk about it. And what you should expect this session is like uh, we have established some familiarity with MLOps from this session as well. Uh, it should inspire you to adopt MLOps in your uh, future projects as well. And it should also motivate you to adopt the right practices that would make your overall ML experience better. You'll be able to build better products ultimately.
Hello, Rajat. Actually, sorry for the interruption. Uh, your voice is actually breaking. Can you try it by like your maybe you can turn off your camera once I can see.
Yeah, I'll just remove my headphone. Better now? So, is it better?
Yeah, it is better.
All right. So yeah, the fourth point is like I would like to touch upon what you should understand, or what should be your learning path to become an ML engineer from the point where you are. Right? So we'll touch upon all these things. So the whole thing is in 1 hour. I'll touch upon this, all these things, but it's not a hands-on and workshop. So I would urge everyone to go, start learning the things, do some hands-on.
I think due to some technical issues, sir got dropped off from the meeting.
Yes, yes. Maybe let's wait for
Yeah.
him. Uh, so sorry for the inconvenience. Actually, our speaker has some issue with his network, so I think he logged out. Let's wait for some time.
I think Suresh joined back.
Yeah, it's on. Maybe you can share your screen. Rajat.
Hi, sorry, I'm back. There was some network issue.
Yeah, it's fine. Maybe you can share your screen.
Yeah, I'm sure. So where I left, I think I was on this slide. So I was talking about DevOps, right?
Sir, sorry to interrupt. I think we missed you in the second slide itself. Eh, Yeah.
Here is it. And then,
Okay.
all right, so I'll start from here. So agenda I've already covered. We'll be touching upon MLOps, what, why, and how, tools and technologies, market opportunities, etc. In objectives, I'll be touching upon what you can expect from this call is you should get inspired to adopt MLOps. People should be motivated to follow the right practices, and they should also be able to understand what they need to learn to become ML engineer at the end of the day. So these are the expectations from this session. So before we start with MLOps, I think the key thing to understand is DevOps, uh, you know which is a practice that allows the teams to deploy your application in a faster way, in a safer way, and it basically allows teams to have a better collaboration, right? So there is no silos, right? There are no teams sitting differently, working on one team working on development, other team working on just deployment, and there is no there's no communication between them. So the idea here is to bring them in one team, build a cross-functional team, and also build the tools and methodologies and practices to allow the teams to deploy their code to the production environment uh, in a safe manner with test in the pipeline, release in the pipeline, and monitoring in the pipeline. So basically, the idea here is to automate the deployment. Basically, what you would do manually. So first step is to integrate your code in some version control, where everyone's code is getting merged into one place where it is versioned. You can handle the conflicts, and everyone gets the latest code. They can see the latest code always. So that's the tool. First step is in a continuous integration. It's an integration basically, and you keep on integrating your code in a version control. And then the delivery basically. So delivery is complex. Basically, it requires multiple things. Like you cannot just deploy; you have to test as well, automated tests basically. And then deployment should be automated on a click of button.
So and the versions and all should be tracked to which deployment that version, the commit version is connected to. So all these traceability of your deployment should be there. So how this helps, basically it allows you to deploy your code in a quick, with the higher frequency. You can deploy daily, you can deploy multiple times in a day, you can deploy in a week. You can choose based on your comfort level, but idea here is to not to hold your code to your lower environments for longer time, or even the in the Git repository itself. It has to go to some environment to generate the value for the business. So the idea is to continuously keep on doing the build, development, build, and then test and the deployment. It should keep on, you should keep on doing it frequently. So this is DevOps basically. So DevOps is like development plus operationalization of your uh, application or your code that you have written basically. Now going further in more detail, DevOps basically. So in DevOps, what is changing? What changes when you deploy, right? From the let's say you were yesterday, right? From today, what changed usually? You change your code, right? You evolve your code, you refactor your code, you add more features, you change your configuration sometimes. You also change your databases. You add one more column, you drop a column, you change the data type of the column. So all these changes you keep on making. So the idea of this whole pipeline should be to handle those changes and also track what is getting changed, and is this change is really affecting my product eventual features. Are they really breaking or not, right? So that should be part of your CI/CD pipeline. So the flow is developer basically writes the code on their local machine using some tool like some Visual Code or IntelliJ, and then once they are satisfied on your local machine, then they just pull to a version control system, and from there the CI/CD pipeline kicks in. Usually, it is in some products it's automatic. Once you commit, it automatically gets triggered. Sometimes it's push based, when someone clicks on a button and it starts the pipeline. So it depends on the comfort level of the team. Usually when your CI/CD pipeline is quite strong, it's able to test all the scenarios in the CI in the pipeline itself, then people usually do it commit wise, right? But that's little, requires lot of discipline and hygiene. So people usually, most of the cases, they prefer to trigger it manually, and then this pipeline basically takes all the code, integrates all the code from multiple people, right? And it basically builds the package. If it is a Java project, it builds a jar. If it is an executable like Docker, it straight away builds a Docker and deploys to Docker Hub or any other Docker repository, and it can then deploys to some infrastructure. And the infrastructure provisioning is also happens through a code, which is usually like Terraform, or CloudFormation, AWS. These kind of tools people use to build your infrastructure using the code itself, not manually. So if you do it manually, then again it defeats the purpose of the whole DevOps paradigm that or practices that we are looking to follow. So this is the whole very high level picture of DevOps. So this we should understand first if we want to move ahead to MLOps. The idea is we are just multiple people are writing the code. There can be two people, there can be 10 people, or there can be 20 people, right? It's very hard to manage if you don't follow this paradigm, right? Who is deploying what version they are deploying? Is it really breaking? Who is gonna on the you know deployment? So this is going to be very very complex if the team sizes are you know uh, huge. Even for one person it is complex, right? You might not be aware of what you did in the past, right? So it's better to have the CI/CD pipeline and the whole DevOps practice in place. Now coming to MLOps, similarly to DevOps, right? It also tries to automate the whole ML engineering, basically, like building, right from building the models to testing the models. Even before building the model, how do you create the features? data processing, everything should be automated. Now, usually people tends to, normally people start with Jupyter notebooks, right? They just write the code there, do some experimentation. But most of the cases, it stays in the notebooks, right? It doesn't see the light, right? I mean, the reason is because the whole ML ops is not there, because you cannot test it out. It's just you are just building a model which you are just testing out on the local machine. You are finding the accuracy, precision, recall, and all these things. But how does it matter to the business, right? Until it is deployed to in some sense, right? It should be available to the people to use, right? So the whole idea of ML ops is to streamline this whole process. And how it helps? Basically, it helps in version tracking. You can track the version of your model. You can track the version of your features. You can reproduce your models because you know all the versions that were used to build the models. So if you don't keep a track of the version, you cannot really go back in time and rebuild your model. So this basically whole idea is to merge DevOps practices, machine learning, and data engineering, and applying them and automate the whole and streamline the whole process, right from gathering the data to data pre-processing, which includes data cleaning, data validation, data feature engineering, and then data filtering, getting the balanced data out for your experiment. So all these, the whole life cycle has to be managed. That's the MLOps in a sense, basically. So at very high level, basically, as I already touched upon, there are primarily two phases. One is experimentation, where you identify the problem statement, then you try to collect and analyze the data. Most of the time, since you do it on your local machine, you don't get the whole data, right? Because there could be security reason, there could be data volume reason. So you just get a snapshot or a small sample of the data on your machine, right? And then you choose your ML algorithm based on your data set and the problem at hand you have, and you do some dirty experiments on your Jupyter notebook, or any other notebook available like Kaggle or something, right? So you do that, right? I mean, and then you fine tune the database. But ultimately, the experimentation is not just enough, right? So then all the code base, or whatever the learnings or whatever you have achieved as a part of experimentation should go into the productionization of your model. So that's where you have to build the data pre-processing pipeline, where you should be able to process the data. If it is large volume, you should have the capability, infrastructure capability, as well as the architecture should be in place to process that huge amount of data. Sometimes it is huge, sometimes it is not. If it is not, it's okay, but still you should have a deep data pre-processing pipeline. Then model training, it depends whether you are using GPU or not, also matters, whether it requires multi GPUs or not. So all these scalability factors while doing the model training also matters. So you have to keep an eye on that. uh, then how do you evaluate your model? There could be multiple ways, right? So it has to be embedded in your code, right? It has to be automated as well. So you cannot just manually evaluate your model. It has to be written in a proper scripting, should be there, proper uh, methodology should be defined, and then comes the model inference, where you provision your model somewhere, whether it's a streaming system, the real-time system, or it's a batch processing. It can be a REST API, right, which is directly connected to some web application or any other service. And then the last part is the monitoring. You should be able to track what your model is predicting, and then that whatever is predicting should go as a feedback to your experimentation, and then eventually to your data pre-processing, and the whole life cycle continues. Okay, so I'll just take a pause here just to absorb this. All right. All right. So moving to the MLOps, the whole logical architecture, in a sense, it's quite similar to what I was showing on the DevOps slide, right? But here, what is dynamic? What changes, right? It's quite complex. It's not as simple as in the DevOps, right? Here, what changes is data, right? Most of the time your data changes. Earlier you might have built your model using 1 lakh records. Now it has 5 lakh records, right? So your model will be performing differently. Your data set has changed. Your time at point at the time at which you got the data has changed. So now you got different things. Your features change. You might have got better idea to change the features, right? You have derived more features, or you want to do it again. So that is also changing. Your hyperparameters are changing. Your whole model architecture changes, right? If you are using layers, you change the layers, right? And if you are just using normal ML algorithms, so in the first model you might have used the random forest, in another you might use XGBoost, right? So your model architecture itself change. So how do we keep a track of all these dynamic things, right? I should know what is happening. There should be some governance on top of it. So that's where the whole data pipeline, this whole data preprocessing pipeline comes in, where whatever you want to achieve as a part of a feature engineering, as a part of your data cleaning, data validation, should be part of your data preprocessing step in your whole pipeline. This whole is a pipeline basically, from here to here, and it should be triggered automatically. It should be able to fetch the data from some data storage, and it should be able to do the pre-processing automatically without any manual intervention. Should that's the work that this data scientist should do, or data engineer, or anyone else who is working should build the pipeline, or write the script such a way that, in such a manner that it can be triggered without any manual intervention. It should just be seamless, right? And then whatever data processing is done, it generates the features. They should be stored somewhere in the feature store. The reason of storing is this data preprocessing may take time, right? So why should we, let's say I just want to go back in time and I want to use the same feature set which I processed earlier. So I don't want to do data preprocessing, right? So that's why it's important to store the feature. Sometimes the feature generation process itself is quite time consuming and resource hungry. So we should keep the feature somewhere in some data store. And another reason is I should be able to do experimentation on different feature set. I should be able to fetch the features based on certain filter criteria, right? Let's say I'm building a model which includes the data from men, male and female, right? So I want to build a model which has 50% male and 50% female in the data set, right? So if I have the feature store, I will be able to extract the balanced data, right? Or let's say I want to build a model where I want to just check how the impact of male or the female is. I want to build a model where 75% or 70% is male and 30% is female, right? So that flexibility is there if you store the features in a feature store. And then the model training kicks in. Model training basically depends on your model, right? What kind of model you are training. If it is GPU based, then you require different set of different infrastructure. It becomes complex. If it is simple, then you can train it on the uh, embedded machines, or it can be offloaded to some other remote machine, but it is less complex than the one if it is GPU based. And features also can be complex. Features can be simple structured features, right? Tabular forms. Other features can just be unstructured, like audio, video, right? Images. So you cannot keep all the binary data in the feature store. So you store the metadata in that case in the feature store, and your actual data lies in some file system, let's say S3 or on Azure Blob Storage. So that's how you store the unstructured data like images, and that's how you deal with the unstructured feature set. And then after the model training is completed, it publishes the model to a model repository with some version and some more details about the model, like what was the feature set it was used, what was the what were the hyperparameters were used. All these things, whatever were used to train the model, are kept inside the model repository, tagged with some versions. And it also gives you the view of the metrics of the model, like ROC curve, other important metrics around the model. So once you log into that model repository, tool, then you will be able to see for which model version the ROC curve was like this. So you should be able to even compare basically multiple versions of the model. And then there's the next step is, what is the right model for me to deploy, right? So in the model evaluation also, you write some scripts and thresholds that it should be triggered automatically. It should be able to fetch the models from model repository and evaluate based on the code you have written to evaluate, as well as the thresholds that I want 75% accuracy. I don't want to deploy any model which is less than 75% accuracy, right? So this will skip that. This will not deploy that kind of model. So if there is no model available to deploy further, a better model than what is already deployed, it will just skip the step, right? Otherwise, if let's say I get a 80% accuracy in the model, right? So it will deploy that model automatically, and it will go to your either an API or streaming system or a batch-based system. It will deploy to that basically. So it will fetch. I think this connection is. It will fetch from the model repository the same model version. And once it is while it is running, then it will gather the logs. It will will do the monitoring, and whatever the user feedback you can have in your applications, the user feedbacks as well, that basically user can say, okay, this was good or bad, or you can basically do that way as well, and get the data back to your raw data, so that you can get that as a feedback to your the whole model training pipeline basically. So this is the logical architecture. I'll talk about the tools now. So what I've done is I've just overlaid the tool sets which could be used. They are just limited. I mean, there could be many options, right? And they're just indicative. Like for experimentation, use Jupyter notebooks, right? For version control, mostly the Git is used most of the time. For model training, PyTorch is used, TensorFlow is used, Keras is used, right? Many different things, multiple platforms basically. So yeah, data preprocessing also depends whether it's very huge volume. You're processing audio, you can use Kubernetes. If you're using a lot of structured data itself, but it is in TBs probably, right? So you can use Spark. Similarly, for videos you can use Kubernetes, or if it is just a simple, very less data, you can just simply do it on a single machine, right? So it depends on the requirement. Data preprocessing itself is a quite complex thing. I think that's the main. I would say it should have the highest weightage on the whole overall MLOps pipeline. So you should be very uh, proactive, and you should follow the right practices, do it correctly. Once your data is good, your model eventually will be good, right? So ultimately all depends on the data, how you prepare your features. So that's the major basically um, uh, thing that you need to take care of. Raw data can be stored in multiple things like S3 bucket, any normal RDBMS like Oracle or MySQL, Databricks, Snowflake. It can be anything, right? The raw data can come from anywhere, and you can store your features in Feast, or it can just simply be MySQL or Postgres. It depends on how complex the problem you're dealing with. For the model repository, it can be MLflow, or there are others as well. WNB is there. There are many tools these days. MLflow was initially, it was the one which was prominent, but now there are more tools as well. And then for the model inference, it can be Kubernetes if you are doing batch based inference, or it can be Fast API if you are doing REST API. So for logs and all, EFK, Elasticsearch, Elastic, Fluentd, and Kibana can be used as a solution. So these are just open source solutions. Most of them are. Snowflake is not, I think. It's definitely is not. But most of them are open source. But you have to integrate them. You have to stitch them together to build this whole platform. There are already existing platforms which can be leveraged, which makes your life slightly easier. Are like AWS SageMaker, it's not free. Azure Machine Learning also is not free. Google Vertex AI is there. Databricks is there. And Qflow is there, which is open source, and it is also compatible with most of the cloud. It runs on GCP, it runs on AWS, Azure as well, and you can also install it on your on-premise system, on-premise infrastructure. So these are the platforms. I'll just go back here and let you guys absorb a little bit.
Rajat, this is Deepak. Uh, can I have a question? Is that okay at this point?
Yeah, please go ahead.
Yeah.
Yeah.
Okay.
Because now things are residing at different places,
Hmm.
how does one coordinate with different, say, on Kubernetes, Airflow, Feast, and whatnot?
Hmm.
How one coordinates all these things and
Hmm.
just have one single snapshot? I mean, I need to check one single version on single version of data. So how do we handle all that?
Right. No, I think this whole connected, I mean, the feature set which is getting stored here, right? It will give you the version of the feature set. So the feature set basically it goes as an input to your model training and gets stored in the model report. So this whole lineage is there. You can keep a track. But I agree with you. I mean, since we are not using any platform in this diagram at least, it's very hard. It's a little harder to track. So that's why we have the platforms, right? Like these Kubeflow, we have SageMaker. All these things gives you the more streamlined and one view basically. That's what I think is required, because it becomes harder if you use multiple types of tools, right? It becomes
Yeah,
harder.
it becomes very cumbersome to handle eventually. Yeah, right.
Yeah. But it can be managed if you do it correctly. I mean,
Mm-hmm.
it can be managed. It depends on whether you want to shed, if you want to use a ready-made platform. I think Kubeflow can give, solve a lot of your problems.
Okay,
Uh,
thank you. Yeah.
yeah. So moving to the MLOps, implementation, or you can say the practice that we implemented earlier was Vakyansh. Basically, it was heavily we used that practice. We automated most of the thing, right? We were able to process huge amount of audios. It was a speech recognition project. We were able to process huge amount of audios in very few days, which would have taken months basically. So we automated this whole thing. We were able to build a lot of language data sets in more than 22 languages, just because we built this whole MLOps platform, kind of, you can say platform as well, right? So we built this whole MLOps platform that was able to fetch the data from the internet, open data, open publicly available data from internet, and then it was able to gather a lot of information from the data automatically. Like we were doing language identification, we were filtering the noise from the audio, and a lot of things we were doing. So it was all automated, right? As you can see the tool set here, and the whole model training pipeline, everything was also automated. So ultimately, this project basically, this one we basically built it for more than 22 languages. I think for pre-training it was more than 50,000 hours of data we used. I think 20,000 or something like that, right, in the range of that. So we used huge amount of data in model training, and we were able to give best data to the model training, because the whole metadata was also there. We were able to filter out the data, what is best for our model. We could fine tune, or you can get the fine tuned feature set from our data set that we processed. We processed thousands of hours of data, but we didn't use 100% of the data because of the data, some issue in the data, some data balancing issue, and all these things. So we eventually were able to build good model, because the whole data pipeline was good, the whole model training pipeline was good, right? We were able to create multiple versions of the model very quickly. So that is one example of the project where we implemented it successfully, and it really gave us the value out ultimately. So you can check this link out basically. Let me move to the next slide. Yeah, so Tess, I want to touch upon this point because this, I think, not many people should be doing. This is something new for you, right? So you might have heard about TDD, right? Test-driven development. So we apply this concept of writing the test cases first, write a filling test case, and then write the corresponding code, source code to make that pass, and then refactor it and then make it fail again. So you basically go in circles and incrementally you keep on adding and more test cases and eventually more and more code that basically you want to build upon, right? So I am applying the same concept here in the feature engineering because I see most of the time people are only working on their notebooks, and the code becomes little dirty, right? Let's say I ask someone, it happens some most of the time, and sometimes if you don't follow it, that I ask someone, okay, let's release it, let's deploy it to some environment. This whole whatever you have done, right? This whole model, it's not there, right? Because the whole Jupyter notebook, the notebook that the code you have written is not that, it's not meant for that, right? So what we are suggesting here is you should write the test cases for your feature engineering as well. So, and write it for a mock test, data, not the whole lakhs of records you should run to test your feature, whether your feature engineering is working or not, right? You can just write for 10, 15, or 20 records, right? And then see whether you are able to write the proper features, functions or not, right? So rather than, doing it in the whole data set and writing and testing it on the Jupyter notebook, write the proper functions which are executable, and check into your MLOps, version control, so that it can be picked up by your MLOps pipeline and eventually reaches to the production basically. So it doesn't make sense to keep on writing the code just on your local machine just for the sake of that it is working. Write the proper test case so that if you change anything as well in the future, you will get a feedback, right? You will understand whether whatever you're doing now, is it really breaking the other features or not, right? So as a practice, always write the test cases for writing the feature functions. This is something I think we learned the harder way. My team as well initially, since it is like we followed test TDD in our normal application development, but we were not following initially in our feature engineering. So now everybody is following that practice. Now I can see the improvement, and we are able to build the whole pipeline and build the better models in a faster way now. Initially it might take some time for you to do the setup and write the test cases, but in the longer run it will definitely save time and the quality will also improve. I can have another session, the whole workshop on this, 1 hour workshop basically on this topic only. Okay, so how do we say that what it takes to become an MLOps engineer, right? So it is not an easy thing, right? Because it, as you know, right, requires data engineering. You should know data engineering. You should be able to process large amount of data using distributed computing architectures like Spark or any other architecture you can use. You should know DevOps well. You should know Jenkins, Circle CI, CI/CD, overall CI/CD tools. Some orchestration tools like Airflow. I think Luigi is there. Temporal. There are multiple tools. You should know the cloud solutions, because if you are on cloud, then knowing one of the cloud will be an added advantage to become an ML engineer. Uh, Docker, everybody should know, because it's very hard to do the implementation on a bare Linux machine every time, right? So Docker is really a boon, right? I mean, it just makes your life very easier if you are able to write your whole code and bake it into the Docker file, right? It becomes a lot easier to not depend on the installation of your the whole tool sets basically that you require your model to run. You can just bake it into a Docker file. Kubernetes is very much important if you want to do a lot of distributed processing, especially the unstructured data sets like images and videos and all. Linux, you should know the basic Linux commands, right? So it should be, it's a must skill, I would say. Without that, I think It's not going to work. uh, Python, some language, Python, JavaScript, MLOps engineer should know, and eventually they should know what data scientists are able to think, not into that in depth, but they should know what is, random forest, what is XGBoost, what are the, other neural networks, RNN, and all. They should know basic. They should know, basic understanding of all these things, if not too in depth. Yeah, and the MLOps frameworks, it depends, like whatever you want to use, you can choose anyone and learn. Like Kubeflow you can learn, MLflow you can learn AWS SageMaker. So you cannot learn all the things definitely, but you have to pick and choose your data, your stack, so that it touch upon all the aspects of MLOps in engineering. Uh, Moving to the next slide. Yeah, let's me check the time. Okay. So yeah, I think most of the time when we work on ML projects, most of the time it doesn't see the light, right? As I said earlier, reasons are, we'll talk about the reason, but these are the stats from very, renowned companies like McKinsey, Gartner. They're saying that 50% of the models only succeed, right? Gartner is saying 53% of the AI projects ever make it to prototype to production. VentureBeat is saying 90%, they never make it to production. So these are stats that I think we should reflect upon why it is happening, right? Why in the industry we are doing a lot of experimentation, we are doing a lot of prototyping, but it's not going to the production. So the first point I think that we touched upon, today, that model development is not getting done correctly, right? Because most of the time, uh, whatever the core data scientists are writing, right, that is just the code that they are able to run on their machine. Probably they are able to evaluate, they are able to get the stats out of the model, but that model just sits on their machine, right? It doesn't go and it doesn't make any use for the business. So until unless you have the ML ops in place as a platform or as a practice in your organization or wherever you are working, it is not going to add any value. It is going to be, you know dead very soon. So this practice has to be there. Without that, I don't think any company which is, or anyone, any project would succeed without MLOps, right? I mean, that's, you cannot just be experimenting, it has to generate the value. Service complexity, right? Yeah, I mean, again, it ties back to, how do we make it available, how do we make it available to the rest of the team, the business people, or it should generate the value, it should be integrated with your existing tech. Then only it will generate your, it will generate the value for the business. The third one is the data access and security. Most of the time, data scientists, they don't get the data on their machine or and their local environment because of the security reasons. Even if they get, it's like, very less, right? Or obfuscated. I mean, it is like masked, right? I mean, it's good if it is masked. I don't think that there is any problem. But the point here we are trying to make here is basically they don't get the proper data itself, right? Because it's on their local. Who will give the whole data to data scientists on their local machine? So these are the, problems I think, and by applying the MLOps, these kind of problems can be subsided, most of the time. And I think if we have MLOps in place, we will be in a better position to generate more value to the organization as a data scientist, as an ML engineer, or as any other techie. Basically, I mean, it should be part of your, company's tech stack. All right, I think so. I'll just move to the next part where I'll just touch upon Black Basil technologies. Before that, I think I'll just take a pause here.
I think, Rajat, you can continue. We will take those questions later.
All right. So I think we have time. All right. So Black Basil technologies. So this I started this company, right? I mean, the whole purpose was to provide the state of the art solutions in data engineering, AI, cloud, and DevOps. So we did a lot of projects in AI space, where we were able to build the whole lead generation and scoring engine for one of the clients in US, and uh, it went well basically. And other thing we are doing is in the speech. Again, we are trying to build a speech emotion detection system, where you can just get the audio and detect where the person is sad or happy, or he's basically uh, not neutral basically. So it will detect. So this research is going on, and we focus on building the solutions basically, which are ultimately going to be you know innovative for our client, and disrupt their industry where they operate in. So that's kind of objective, or that's kind of motive we have, whatever the projects we begin. um, so overall, we basically work into all different areas like hyper automation, where we try to leverage the cognitive abilities like document reading, all these capabilities in the whole automation of the process. So we try to you know reduce the manual work, reduce the errors, and induce the automation that can save a lot of time and make the whole process smoother and seamless for the organizations. We basically have expertise on multiple platforms like UiPath and other open platform, or other platforms like Ira, Commodore we have partnered with. Similarly, on data engineering, we work on engineering using Snowflake basically, and we basically build the whole all the layers, the whole business layers and data visualization, uh, data visualization we do. And on top of that, we also try to build the predictive analytics on top of that data basically, that which is useful for the business. So AI ML, we worked on, we are working on conversational AI at this point. We are building a product right now. We also provide MLOps as a solution to the companies, to the clients. And yeah, so multiple things we do in AI ML, like we work on a cricket analysis project. We also written a white paper on that. So it was to analyze the cricket, the multiple facets like the ball trajectory, the batsman hitting capability, like whether he was able to hit properly or not. All these things we were able to do it using the existing frameworks like YOLO framework and all. Similarly, we work in DevOps and application development. All right. So white papers, I think we have written this white paper as I was talking about. You can read that basically. It is about real-time cricket match analysis. So one of our team member, he was working on that. I think he is from Triple IT Guwahati itself, if you know him, Mushtaq basically. So he wrote that paper. We are in process of writing another paper in speech emotion recognition. That would be a research paper very soon rolled out from our side. All right, I think we are done. Thank you.
Thank you so much, sir, for this talk. We have a few questions which I think
Yeah.
I'll ask you. Those are from YouTube. The first question is from Hidayat, sir. He's asking, does continuous integration and continuous delivery, sorry, does continuous integration and continuous delivery increase the risk of things going wrong in production if some error gets undetected? How should we tackle this?
Yeah, I mean, that's a very good question. I mean, so with more powers comes more responsibility, right? I mean, when you write the CI/CD, you have to make sure that the CI/CD has all the safety nets in the pipeline, right? If you don't have any safety net, then there are high chances that you are going to deploy wrong code, right? That's why we focus on unit test cases, we focus on integration test cases, we focus on automation test cases, even the security test cases. You should be able to statically, you know, read the code and see whether there are security vulnerabilities in the code, dependencies are correct or not, there is a security leak or not. So all the safety nets, as much as you can do, right, in the pipeline itself, you should have. Otherwise, you can go wrong. I mean, that's the answer.
Okay. Next question we have from Shishir sir. He's asking, since you have good experience working on MLOps for speech technology, uh, especially for ASR model deployment, if you want to serve for thousands of users concurrently, what will be the infra?
Yeah, that's a good question. Basically, this runs on GPU, right? I mean, the speech recognition inference will run on GPU. That's on, then only you can get the better results. So first thing is you should use a GPU inference. Second thing is you need a scalable architecture. NVIDIA provides you Triton server, basically. You can try that out. And now these days, Kubernetes also provides the GPU sharing, virtual GPU sharing as well. So you can go to NVIDIA website itself, probably, or you can do the Google search and write the GPU sharing in Kubernetes. You will get the answer basically. So you have to have a scalable architecture which can, serve multiple users at one time, basically, I think.
Okay, sir. Next, sir is asking, how different is LLM deployment in terms of cost, infra, current feasibility?
That's a very long, I mean, long discussion we need for that, because we are also doing some research on that. My take on this is LLM models that are currently existing. I mean, they are quite large models with 7 billion parameters, 13 billion, and all. Most of the cases for enterprises, we should not need that big model, right? The data should be less, the model parameter should be less, and overall size of the model should be less, right? That's what we are trying to achieve currently as we speak in our organization. And once we do that, I mean, the cost per hit on the API should be less, because if you are trying to use a very big model for a very small problem that you're looking to solve, it's going to be quite expensive. The ROI will be less. So that's what I think we need to do, some kind of more work on that. But yeah, deploying the existing models like Falcon or Llama, right? Llama 2, 7 billion, even 7, it requires some infrastructure, which is expensive, right? I don't think we should need that if, let's say, I'm working on a very specific, narrow problem, right? I think.
Thank you, sir. Next, we have a question from Nagraj Adiga. He's asking, how would MLOps respond if client data arrives that isn't anticipated during the data processing step, such as a change in data format or sampling rate?
Change in data format or
Yes,
sampling.
if data arrives isn't anticipated during the data processing step.
Mhm. Okay. So I think in that case, first your data processing pipeline will fail, right? Because you're not prepared your data processing pipeline for that. And I think it's good. Sometimes it's good to fail as well, because if it is failing, that means you didn't expect any something like that, right? So in that case, you can see and check what was the root cause of the problem. If you want to accept those kind of template, you will allow them in your data processing pipeline. Otherwise you will filter that data out, right? So whatever you've written as a pipeline is not static. It may change based on the dynamics, right? Your code may change, your code may also fail the pipeline. So you have to keep fixing all these. That's what you have to continuously do, basically. So, or if you know that I can expect multiple kind of sample rates upfront, then you can smartly write some kind of a code that can handle multiple sample rates. But you cannot basically expect everything right upfront. It may fail, so let it fail. I mean, it's meant to fail as well. It's not going to be successful always. Hopefully I could answer.
Thank you, sir. And also, sir, one question from my side, like how does the build happen for all the three different, like for data processing, model evaluation? If one fails, will it affect the other, or they're like independent uh, in that sense?
Sorry, can you repeat the question?
So, sir, like, if the build fails for one of these, like data processing step, so does it affect the other two in the pipeline also, or they are independent
No,
in that?
that will definitely impact, because if data preprocessing itself got failed, your model, training pipeline will not kick in. So they are interconnected basically, because if you don't have new data, it didn't arrive to the model training step, right? So it will fail. If you basically have changed your code and there is no data change, it will still go ahead, right? It will basically try to rebuild the model with your new code with the same old data, not the latest data which failed the data preprocessing step. So everything is connected basically. The pipeline is whole connected with each other.
Okay, sir. Next, we have a question from Nagraj himself. He's saying, is it possible to implement MLOps with custom pipeline on the customer's premises if customer doesn't want to share
Yes.
the data?
Yeah, it's possible. You can use Kubeflow. Kubeflow basically is a platform for MLOps, and you can do it on premise as well. And Airflow itself. I mean, if you want to handpick the tools by yourself, there are many open source tools as well. So using Airflow and all these are all open source. You can deploy them on your customers' infrastructure.
Okay, thank you, sir. I think we have one question in the Google chat. If I think Deepak, sir, if you want to ask that, since it's your question.
Yeah. So, Rajat, so especially for startup companies, right? Storage of customers' data, be it like speech or text, essentially, it's a challenge for long time, right? So startups can't afford to have that large storage space like for long
Mm.
time,
Mm.
and storing as features also has its own demerits. Say, for example, each features can be different, so it has its own dynamics. So any smart solutions for the same thing that you have envisioned or you've come across, any such things?
Right. I mean, the first step can be to store your metadata in some cheaper storage, some cheaper database, and your heavy data, which you can refer from your metadata to that the location of the file system, to some cheaper storage as well, like S3 and all. And
Hmm.
if it is not getting used, you can put to some archives like Glacier, right, which is very cheap itself, and you can still keep the metadata, right? And whenever you require, you can pull the
Okay.
data from the Glacier. That is
Okay.
one strategy. Other strategy is audio is just a binary file, right? Ultimately, what your model needs can be a simplified version of that as well, right? Like you can
Hmm.
see the numpy arrays probably that maybe we are just trying in our speech emotion recognition project. We are trying to store the feature in the form of numpy arrays basically in the files.
Hmm.
So that may, I don't know the data side, I need to check, but it may reduce the data size as well. So you can
Hmm.
compress the data as well, right? I mean, many strategies you can deploy. I mean, if the data storage itself is the problem.
Hmm.
So
Yeah. Thank you, Rajat.
Vikan, I think there is another question from Vishaguru. Maybe I can read out. Rajat, one question. Can Indian regional languages that do not have any formal scripts format can be scripts format be trained for ASR? Actually, he is asking like if any Indian languages where formal scripts are not there, so can we train ASR model?
formal scripts mean like Devanagari
Means
or
like if they don't have any kind of transcription. I mean like
text.
maybe I didn't get. Maybe like he is asking like if they don't have any script to write that particular language.
Okay. So how do if they don't have anything to any script to write, what this ASR model will do? I mean, because ultimately ASR model will give the text as an output of that audio file. So I mean, the question is a little vague for me. I'm not trying. I'm not.
Yeah, maybe. Yeah, I think like that whatever is speaking maybe can be converted to English. Maybe I don't know. Like yeah. I think it is fine now. Yeah, that's fine. So we can, I think, we can wrap up. So if we don't have any questions, yeah,
Yeah. All right, everyone. Thank you very much for joining.
yeah. Thank you, Rajat, for
Yeah, bye.
yeah
Thank you so
all
much,
the
sir.
session. Yeah, it
Everyone.
was very nice actually. Yeah, we can continue.